Hi, gang. Math 6610. So what I want to do is just give you one more example demonstration of the ANCOVA model. So what I'll do here, there's a really interesting data set. I have to give Andy Field credit on this one. I wrote Discovering Statistics Using R, the textbook that we use. Kind of an interesting example. I can never get that where it actually. All right, attach the data. I should have already had all this done. Daggone it. All right, let me tell you about this study a little bit. What this study was about is doses of Viagra. And let's just dive into the Viagra and see what's going on. So there were 13 subjects who received the high dose, 8 subjects who received the low dose, and 9 subjects who received the placebo. So they came up with a way to measure a subject's libido. Libido is well, look it up. So they wanted to see if the subject's libido changed or if the mean libido was different over Viagra dose. Now, I can look at some means here, and I think this is always a good thing to do. So let's look at the libido over the Viagra dose and just see what happens. So the mean libido for the high dose was 4.85, low was 5.13, and the placebo is 3. So you can see that there probably is going to be a statistically significant difference between placebo and low and placebo and high, and no statistically significant difference between high and low. Now, in the design of the study, they thought that the relationship between the dose of Viagra and the libido of the subject could be impacted by how attractive or I should say, gosh, it's kind of hard to say, how the libido of the partner. Okay, and I think that kind of gets into maybe the sexual attractiveness of the partner and how attracted two people are to each other. So they came in and used partner libido as a covariate, which makes sense, right? So if you run your model, let's just run the base model here of libido and see how it relates to Viagra dose. And we can see that we just kind of squeeze in, or squeak in, if you will, being not statistically significant. 0.053 is very close to the threshold of 0.05, but nevertheless, we do not have a statistically significant difference in mean libido over Viagra dose. A little bit surprising, right? Because I would have thought that the pairwise comparison of placebo to low and placebo to high would have emerged statistically significant, but it doesn't. Now, something I can do to investigate this a little bit further is to look at the Tukey HSD, the posthoc of our model, and we get something that emerges pretty much exactly the way we would think it would be. These two are close to being statistically significant. And of course, the means for low high are so close that we wouldn't expect a low p-value, as the difference is only 0.28. Now, and let me pump the brakes here and explain something to you. I've manipulated this data to create a scenario that I wanted, so it's not going to align with the data that's presented by Andy Field. because I wanted something to happen. Okay, drum roll, please. So let's run the ANCOVA design. So I want to look at the libido again, based on the Viagra dose, but then I want to add in the covariate. Now, again, I want you to run the ANCOVA designs like this because I like to see, given that Viagra is in the model, what does partner libido add to? What does our covariate add to or explain? Some people will argue that you should use a type 3 sum of squares calculation, and I totally understand the logic there. But if you're truly, in my opinion, my humblest opinion, if you're truly focusing in on what does what does the covariate add to the model, I think the type 1 sum of squares does the trick for us. And again, that's something that when you're an ed researcher, those are the things that you have to explain when you're writing up the summary of your results. All right, so look what happens. By entering in the partner libido, we can see that not only is the partner libido related to the subject's libido, we can see that when controlling for the partner libido, that we get a statistically significant difference at the Viagra dose level. So this is where we would want to look at the postdocs. So remember, we have to, what's it called, multi-comp? No. Multi-comp, yeah. And then we'll run our postdocs using the GLHT command. So we put in our model first, and then fact equals P. And then we put in our independent variable, and we want to run Tukey. All right, that should do it. Now let's run a summary of our posthocs and get our pairwise comparisons. And when we do that, we see that placebo to low is statistically significant and placebo to high is statistically significant. Interestingly, the low dose, the mean was actually higher, right? So so the placebo to low, okay, the placebo to high. All right. So I think if I was a doctor and going to use this information to prescribe Viagra, I think what I'm seeing is that the low dose and high dose, uh, statistically speaking, are no different. So I would think that the low dose would be just as effective as the high dose based on this study. Obviously, there need to be more research to be done on that, but so I would think that the prescribing the low dose would be the way to go. Now, just throwing it in here, we can look at the confidence intervals, and again, notice that the confidence interval that is not statistically significant contains 0. The two that are statistically significant do not contain 0. Now, I want to come back up here and I want to point something out. Sometimes I don't think my students truly understand a post hoc comparison that controls for family-wise error rates versus a straightforward. So what I would like to do is I'll tell you what, let me just show you the entire data set. It's not that large. So what I would like to do is I would like to come in and just isolate the placebo and low, conduct uh, uh, an independent samples t-test, of libido over Viagra dose, exactly what I did up here in the ANOVA, and show you the difference, show you how the p-value is a lot lower when we just perform a standard t-test than it is when we control for, using post hoc analysis, control for the inflated type 1 error rate. I'm going to subset this, so I'm just going to call it new data just because I'm not that creative. So I want to choose rows 1 through 17, I believe. Yeah. And then I want all of my columns, that information. Now, if I wanted, for example, let's say, I only wanted to include, 1 and 2, I would just put 1, 2 there. Uh, so I've got a new data set. So to be able to work with it, I need to attach it. Now, let's run a t-test of libido over Viagra. And you'll notice here that the p-value is 0.0271, whereas up here between placebo and low, we have a 0.04. Now, both of those tests are comparing placebo and low, but in different situations. This is just doing a straightwise t-test. Sorry, I'm distracted. My dad's calling. My mother-in-law's calling. All of a sudden, I've got really, really important in my family for some reason. Hope there's no emergency. So let's wrap this up pretty quickly. So this t-test is, again, not taking anything else into account, meaning that there are no other associated pairwise comparisons that are being done on this data set. Up here, there are 2 other comparisons that are being conducted. Therefore, we have inflated the type 1 error rate, the family-wise type 1 error rate, and we have to control for that. And again, remember, our type 1 error rate is inflated, therefore our p-values are inherently low, so we have to correct for that using the Tukey process. All right, so I hope that makes sense. When we do post hoc analyses on ANOVA and ANCOVA repeated measures, which we'll do in an upcoming lesson, these post hocs control for that inflated family-wise type 1 error rate. All right, gang. Again, let me something I want to point out. I skipped through a lot of stuff here. I didn't test assumptions. I didn't calculate effect size or power. That's all been done in previous videos. So if you're in my class, you were expected to watch those. If you're just maybe, I noticed that a lot of people watch these videos who aren't taking my class, which is, in my opinion, super cool. So you might want to check out other videos to find that. All right, gang. I think that's all I got. Take care.